Load schedule is a table that lists all the electrical loads in a building or facility, including their location, type, rating, and power consumption. It is used by electrical engineers and designers to ensure that the electrical system is properly designed to meet the power requirements of all the loads. A single-line diagram is a graphical representation of an electrical system that shows all the electrical components, such as transformers, generators, switches, circuit breakers, and loads, on a single line. It is used to provide an overview of the system and to help engineers and designers understand the interconnections between the various components. To create a single-line diagram from a load schedule, you would typically follow these steps. 1. Identify all the loads in the load schedule and their power requirements. 2. Determine the distribution and sub-distribution panels required to serve the loads. 3. Identify the main switchboard and incoming power sources. 4. Draw the main electrical feeder from the main switchboard to the distribution panels. 5. Add in the distribution panels and their feeders, and connect them to the loads. 6. Include all the protective devices, such as circuit breakers and fuses, in the appropriate locations. 7. Label all the components with their ratings and other relevant information. 8. Review and check the diagram for accuracy and completeness. The process of creating a single-line diagram may vary depending on the specific project requirements and the complexity of the electrical system. It is important to ensure that the diagram is accurate and up-to-date throughout the design and construction process to ensure safe and efficient operation of the electrical system. Here are the steps to create a single-line diagram from a load schedule. Review the load schedule. Study the load schedule and ensure that you have a clear understanding of all the electrical loads in the facility, including their location, type, rating, and power consumption. Identify the electrical components. Identify all the electrical components that will be included in the single-line diagram. This may include transformers, generators, switches, circuit breakers, and loads. Determine the electrical distribution. Determine the electrical distribution system required to serve the loads, including the main switchboard, sub-distribution panels, and branch circuits. Determine the incoming power sources. Identify the incoming power sources, such as utility feeds, generators, or renewable sources like solar or wind, and their ratings. Draw the main electrical feeder. Draw the main electrical feeder from the main switchboard to the distribution panels. Include any protective devices like circuit breakers, fuses, or switchgear that are required. Add in the distribution panels. Add in the distribution panels and their feeders. Connect them to the loads that they serve. Ensure that the panel ratings and the feeder sizes are adequate to handle the loads. Include protective devices. Include protective devices like circuit breakers, fuses, and surge protectors in the appropriate locations. Make sure they are sized correctly to protect the electrical system from faults and overloads. Label all the components. Label all the components on the single-line diagram with their ratings, voltages, and other relevant information. Review and check. Review the single-line diagram to ensure that it is accurate and complete. Check that all the loads are accounted for and that the electrical system is properly sized and protected. Update the diagram. Keep the single-line diagram up to date throughout the project to ensure that it reflects any changes that are made to the electrical system during design and construction. Creating a single-line diagram from a load schedule can be a complex process, and it's important to have a solid understanding of electrical engineering principles and practices to ensure that the resulting diagram is accurate and effective. If you are unsure about any aspect of the process, it's best to consult with a qualified electrical engineer or designer.